Hello students, in this lecture we will study about handling data hazards in software. In previous lecture we have already seen that we can avoid data hazards or we can handle data hazards by using operand forwarding concept. Okay, so the data dependency is discovered when the instruction is being decoded. That means when it is decoded and then execution starts, and for completing its for completing its decode unit or decode stage, we may need the help of the previous instruction to being executed. It needs to be executed. So if one instruction's execution depends on another instruction's execution, then that concept is called as data dependency. Okay, so there is a solution of operand forwarding to avoid these hazards or data dependency. Okay. And what we will do, the control hardware delays reading register R4 until cycle, thus introducing a 2-cycle stall unless operand forwarding is used. That means if we use operand forwarding, then it's okay. Otherwise, what it will do, it will stall for 2 clock cycle. Let me show this picture again. This picture, if we will use operand forwarding, then this will not stall for 1 clock cycle and this will not stall for 2 clock cycle. Okay, but if we will not use operand forwarding, then this pipeline stalls for maximum 2 clock cycles. Okay, so an alternative approach is to leave the task of detecting data dependency and dealing with them to the software. Okay, that the data dependency detection and handling, I have to leave it on the software. So in this case, what will happen? In this case, the compiler introduce a 2-cycle delay needed between this instruction I1 and I2 by inserting no operation. Okay, so in this case, the compiler can introduce the 2-cycle delay. What I have seen you in the previous figure, the 2-cycle delay between the instructions I1 and I2 by inserting NOP, no operation instruction. Okay, like this one, at I1. Okay, I have taken these 2 instructions in the previous figure, that this R4 is the resultant operand of I1, and this is one source operand for I2. Okay, so will the compiler will insert these no operation instructions as follows, like this way. As 2-cycle stalls, then it will insert 2 NOP operations, so that after the I1, when it continues its execution for 2 clock cycles, then at that point of time these 2 instructions will being executed. Okay, in these 2 instructions, what will the compiler do? The compiler can attempt to reorder instructions to perform useful tasks in the NOP slots. Okay, so in some cases, what it will do, it will reorder the instructions. That means it may insert some extra instructions inside. Let I3, let it is the what let same addition, let R7 R8 R9. Okay, so this instruction execution does not depend upon I2 and also I1. So when the compiler will execute I1 and then it will invoke this instruction trying to execute this NOP instruction, then it will reorder the instruction. That means I3 will be going in the place of this NOP. Here we will execute the I3 instruction. Okay, there will be no problem about that, as it is stalled for 2 clock cycle. So you can include 2 instructions, so that when this I2 instruction will execute, will enter into the decode stage, then that will be available, so it can complete its task and also I3. Okay, so thus achieve better performance. Okay, so that the compiler, as the compiler stalls its execution, it halts the execution, and when we are inserting this instruction before this, then it will reduce the clock cycles needed to execute the following instructions, like here. Okay, if I will reorder these 2 instructions, I3 here I3 and here I4, then I3 will started from here F3, D3, E3 and W3. This will be F4, F reorder, then let it's keep it as F4, okay, then D4, then E4, then W4. Okay, so then it will start its execution from here F3, then D3, it is already in the memory, then 3, then D3, like this. Okay, so we don't need to wait for this 2 clock cycle, and within, if we start from here, then within 7 clock cycle we can complete these 4 instructions by using the software or the compiler concept. They are inserting the NOP instruction. Okay, let me draw it again. Okay, so this one, if we reorder like this, you can insert other instructions also. As I have taken in the figure 4 instructions only, but actually in the program there may be more than 4 instructions, so it depends on the compiler actually. Okay, so for this 4 I have reorder like this. You can also put I4 here, I3 here, no problem. Okay, but there must be no stall. Okay, so here in this way, as you can see that here I1, when it will start its decode unit, then this is already present in the memory, so that it can easily fetch and also decode in its decode stage. Okay, so here no stall is required, and this is our NOP operation. Okay, reorder. First it will reorder, or it will take I3 here, then in the NOP it will take I4 here, like this. Okay, so in this way it can achieve better performance. That means in the 7th clock cycle you can completely execute these 4 instructions. Okay, so this is the way in which we can handle the data hazards by using the operands. Okay, but there are some disadvantages of using this NOP, that it the insertion of this NOP instruction may lead to larger code size. The disadvantages is that leads to larger code size. Okay, like this, there are 4 instructions, but here if you will include this extra 2 instruction will be included, like 6, it will become 6. Okay, but NOP instructions inserted to satisfy the requirements of one implementation which may not be needed, and hence it leads to reduce the performance on a different implementation. Okay, as some softwares or some pipeline concepts may not accept this NOP operation. So in some systems the NOP, the no operation concept, may reduce the performance. Okay, if we change this implementation, different implementation may it leads to reduce the performance. Okay, but this is a way in which we can improve the performance, and also we can handle the data hazard. Okay, so this is all about how we are handling the data hazards in software. As we are including compiler here, and compiler is a software, it completely depends upon the software how it will handle the data hazard. It automatically insert the NOP instruction, that is no operation, and when NOP instruction faced, then it will reorder the instruction, and according to the reorder it will start its execution in this way. Okay, in this figure. Thank you.